Hello fellow developers, my name is Warwick White, back again with another update to my dial library. This is the OpenGL version of my dial library, which is an open source dial library for the Android platform. It's got loads of really cool behaviors. For the purposes of this demonstration, I've used the dial as a menu system for this app, so I'm going to dial to the right and show you what this control can do. Okay, we'll do here, you've got a little dial there, put your finger down and rotate. There's a couple of cool things this dial library does. As I'm rotating to the right, you notice that the gesture direction and object direction is 1, and our reverse goes -1, so this library tracks the direction of rotation. Also keeps count of the amount of rotations you've made. You can see the rotation counts going up there. You'll notice it's got a gesture rotation count and object rotation count. This library keeps track of the amount of circular gestures you make and the physical rotations of the actual physical dial object itself, and tracks them separately. Those numbers are the same at the moment. I'm going to explain in a minute why those are the same. So I'm going to quick tap and bring up the settings. Okay, these are all the flags here which show what the library can do. You've got rotate cumulatively, single finger. You've got sensitivity of the gesture, which causes the dial to rotate at a different rate to the gesture. Your angle snapping, minimum maximum rotation constraints, variable dial, which I'll show you in a minute. We'll start out by showing you rotate cumulatively. So at the moment, rotate cumulatively, I put my finger down and it doesn't move until I move my finger. And at the moment, it's on a precision of 1, so for every time I rotate my finger, the dial will rotate exactly once. If I put in non-cumulative, what will happen now is when I put my finger down, the dial will rotate directly to the angle where my finger goes down, like that, and rotates from there. Finger goes down and rotates from there. Okay, now I'm going to put cumulative back on, and as you can see, put finger down, doesn't move until I move my finger. You can work in single finger mode or dual finger mode. Put down dual finger mode. Put my finger down, doesn't move. Put the second finger down and it starts moving. So put that in single finger mode again. This is the sensitivity. This causes the dial to rotate at a different rate to my gesture. So I'll put, say for example, 1.56 for example. Put my finger down, and now the dial will rotate faster than my finger. And now, as you can see, the gesture rotation count and object rotation count are going up at different rates, and it's still tracking the direction there. And that can even be a negative number, so we'll go minus 0.86 for example. There you go, it rotates in the opposite direction. As you can see, it's still keeping track of the object rotation count and gesture rotation count are going up and down in opposite directions, and so too is the gesture direction and object direction. So you can see the gesture is rotating to the right, and the object direction is -1, and the reverse is when I reverse my finger. So that keeps track of everything there. I'll put that back to 1.0 for the time being. Put on angle snapping. Incidentally, literally all of these behaviors can work together in any combination. I'm not going to bore you by showing you every combination, but it does work. So go back to position of 1. Okay. So what we'll do here, I will now show you the angle snap. As you can see, that's snapping into position there. If you watch closely, you'll notice it's rotating freely between snaps. That's actually to do with the angle snap proximity settings, this number here. Now, these numbers are probably don't mean anything to you. That's because this library calculates angles in ratios of 0 to 1 instead of 0 to 360. So that represents 45 degrees. That represents 1/4 of that. If this number is 1/2 of this number or above, then there will be no free rotations between snaps. So I'll demonstrate that. Let's go 0.125 for the time being. What will happen now is with the angle snapping, there'll be no free rotation between snaps. It'll just snap straight into position, as you can see there. Put that back again, 0.3125, and as you can see, it's rotating freely between snaps again. Okay, so we'll take the angle snapping off. Minimum maximum rotation constraint, that prevents the dial from rotating more than -2.5 to the left and 3.2 to the right. So I'll quickly demonstrate that. See that clips at the boundaries there, and I reverse my finger. It detects I've reversed my finger and clips at both ends. That's quite straightforward. Of course, those could be any numbers there. We'll take it off. Use variable precision. This is a very handy little behavior. What this does is, this basically uses these numbers down here. So when that flag is set, that variable precision, what happens is the dial will now detect how close I'm rotating to the center of the dial. So with these settings here, when I'm rotating close to the center of the dial, it'll rotate 4.5 times with a circular gesture I make, and as I slide my finger to the outside, it'll use that number there. So I'll show you that. So as you see, it's rotating slow to the outside, moves to the inside, and it speeds up, slows down to the outside. That's a pretty cool behavior. These can be any numbers. I'll go say -2, +2, and that'll do something quite strange. It'll rotate one way to the outside and move to the inside. It'll slowly stop it. It'll actually start reversing, which is pretty interesting stuff. So we'll put that back to, for the time being, we'll go 150 naught. As you can see, that's rotating extremely fast. Now, variable dial curve, this is a new behavior which acts on the variable dial precision, and it's one of the reasons why I'm actually re-uploading this video. This is one of the new behaviors. What happens with this is the variable precision, when this is on, causes the acceleration and deceleration to happen on a curve. So as you can see there, it's rotating very slow to the outside. To go to the inside, it still accelerates. Now notice I can actually get a lot of accuracy there on the outside and move it very, very slowly, even though the inner precision is 150. So if I take the variable dial curve off, for example, with those settings, as you can see, I don't have the accuracy. So obviously the reason I added the variable dial curve is in case the user wants to have a very high inner precision but still be able to zero in very easily on an exact angle. The positive curve, this causes it to decelerate to the outside, and that obviously accelerates to the outside. Now I'm going to show you the fling behavior, which is pretty cool. Basically, the dial can now fling to spin. That corresponds to these 5 numbers here. These 2 are the fling tolerance. So with these settings here, I have to fling, say, 150 pixels and release it in 250 milliseconds or less for it to be recognized as a fling. And that fling will actually trigger a spin animation. So these numbers here, that's the start spin speed, which is 10 rotations per second, and that will slow down to 0 rotations per second over the period of 5 seconds or 5,000 milliseconds. So I'll demonstrate that. Little thing there. There you go. That's flung, and that'll slow down. Okay. So what happened there is, now what's happened here is, as you can see, that went from 10 spins per second to 0. So you can see that actually slowing down there, nice and slowly. Of course, you can spin in both directions. You can catch the spin before it ends if you want to. Now, another cool thing about this, if you want to do some strange things, if for some reason you want it to speed up instead of slow down, you can do that as well. That will speed up. If you actually set these 2 numbers to 0, what happens is the speed of the fling, or the spin animation, will be relative to the actual speed of the fling itself. So, for example, if I fling it slowly, it rotates slowly. If I fling it fast, it rotates fast. And again, you can capture that before it ends. So that explains that. Obviously, you can change the time in milliseconds there. So that explains all those behaviors. Now, all these behaviors, again, can be used in any combination. So, for example, I turn the angle snapping on and min-max constraint, and as you can see, it snaps, and it'll still capture there at the end. Or if I want to, I can actually, have I got the fling on? Where's the fling? Okay, yeah, fling's on. So I can fling that, and you see the angle snap is working with the fling, and it's also working with the min-max constraint. Now, this dial library also supports distorted dials. So I'm going to go to this part of the menu, dial to the left. You see you've got a distorted dial there, and all the behaviors that I set in the main library actually persist here. So that's using angle snapping there, as you can see, and you can fling it, and you can rotate the device there, as you can see. So all those behaviors that you set over here persist on that dial. So if I go to here, for example, and I take min-max off, take the angle snap off, and take the variable precision off, for example, and then kind of go back to here, as you can see, it kind of behaves normally. Now, another really cool thing about this library is the way one dial can act on another dial. To demonstrate this, I've actually used an analog clock demonstration. So I'll go over to that part of the demonstration here, and tap on the screen, and it'll go to the current time. So this demonstrates how one dial can act on another dial. So if I move the hour, it acts on the minute, and the minute in turn acts on the second. Click the minute dialog there, that will rotate the minute will act on the second, and that will also act on the hour. go to the second action on the minute. If I dial it quickly, you can actually see it acting on the hour there. That's all cool stuff. So that kind of concludes this demonstration. When I upload this video to YouTube, I'll be publishing the location of the Bitbucket repository where you can get it. It's free open source. I've recently added a donate button, so if you guys are feeling generous and want to donate to the open source course, you can do that. It's got loads of feedback, it's got loads of callbacks, and it's very intuitive, very responsive, very stable now. There's a couple of other libraries on my open source repository. I've got another library that does exactly the same as this. Instead of using OpenGL, it uses Canvas and extended views. The alpha blending and the way the dials act on each other aren't as good, and it doesn't support distorted dials rather, but it's actually much easier to use. Before I quickly close, I'll show you how cool the alpha blending is on this as well. As you can see there, you can actually see the second through the minute, and you can see the hour through the minute there and the second, so really cool little transparencies there. Okay, so I will bid you developers farewell. Thank you for watching my video. I appreciate any feedback, and I will bid you adieu.